There's a secret buried in the heart of space, darker than night, older than stars, and stranger than anything we've ever imagined. Black holes. They've long been seen as cosmic executioners, final destinations for matter, light, even time itself. But what if they're not? Ends but beginnings. A new discovery by the James Webb Space Telescope may be pointing to something almost unthinkable, that we, all of us, may already be inside a black hole. And the evidence is hidden in the way the universe spins. Let's rewind. A black hole forms when a massive star collapses under its own gravity, becoming so dense that not even light can escape its grasp. At its center lies a singularity, a point of infinite density and curvature, or so we thought. But over the last few decades, physicists have proposed a daring idea that black holes aren't just dead ends. They may be bridges, cosmic tunnels, that lead somewhere else entirely. And now, the James Webb Space Telescope may have caught a glimpse of the truth. Launched in December 2021, JWST is the most powerful space telescope humanity has ever built. It doesn't just observe stars and galaxies. It sees into the past, capturing light that has traveled for billions of years. In March 2025, JWST returned an image unlike any other. 263 galaxies, billions of light years away. But something was, almost two-thirds of those galaxies was spinning opposite to the Milky Way. This wasn't random. It suggested that galaxies across the universe may share a preferred axis of rotation. But if the universe is coordinated, why is our galaxy out of sync? Some physicists believe this could be evidence that the universe itself was born spinning, and that our orientation is simply different from the dominant flow. But others believe the rotation pattern we see is the signature of something much deeper, a universe born inside a rotating black hole. Here's where the theory turns wild. Nikodem Popovsky, a theoretical physicist, proposes that black holes don't just compress matter, they bounce it. When a star collapses, its matter doesn't get crushed into a singularity. Instead, it rebounds and expands. Not in our universe, but in a new one. A new universe inside the black hole. This bounce creates an explosion of energy. A cosmic recoil, a big bang. Sound familiar? This idea isn't entirely new. In the 1930s, Einstein and Rosen theorized that a black hole might be connected to a white hole, a structure that expels matter. Together, they'd form an Einstein-Rosen bridge, or a wormhole. In theory, this bridge connects to points in space, or even to universes. Imagine every black hole in our universe is a door, and behind each one, a new cosmos unfolds. Now take this further. If our universe came from a black hole, that means it's contained within a larger universe, like a Russian nesting doll, and inside our own black holes, more universes. Each layer holds another. Each collapse births something new. Infinite realities stacked one inside another, forever. But if that's true, why don't we see anything? Because the event horizon, the boundary of a black hole, traps everything. Light, matter, time, even information. If we are inside a black hole, the walls around us are invisible. We can't see the parent universe, and no one outside can see us. We are cosmic prisoners, or children waiting to grow. This reimagining of the Big Bang changes everything. Instead of an explosion from nothing, it becomes a transition, a phase shift from one universe to another. The rotation, shape, and structure of galaxies, all inherited from the black hole that birthed us. The cosmic microwave background, a thermal echo from our black hole's interior. The uniformity of space, a side effect of the compression and rebound. It fits, and it terrified. According to Popovsky, as matter collapses into a black hole, it reaches an incredibly dense state, but not infinite. Before it can form a singularity torsion, a twist in the fabric of spacetime pushes back. Like a spring pulled too tightly, it snaps the result. Expansion, inflation, creation, what we call the Big Bang, may simply be the other side of a cosmic heartbeat. But there's a catch. We can't see beyond the event horizon, and that makes proving this theory nearly impossible. No telescope, not even JWST, can peek past that boundary. It's a cosmic firewall, a veil of eternal shadow. So how do we know if it's true? We look for echoes, for asymmetries, for signs like the unexpected spin of distant galaxies that suggest something isn't quite right. Here's what's even stranger. Some galaxies appear older than the universe itself. Based on distance and redshift, they shouldn't even exist yet. Some stars form too early. Some galaxies grow too fast, and the rate of cosmic expansion doesn't always line up. Maybe our measurements are wrong. Or maybe our assumptions are, if black hole cosmology is real, then everything changes. Our universe isn't the universe. It's a universe, one of many. A node in an infinite tree of realities, branching out from collapsing stars. We are not at the center. We are not at the edge. We are in between. So what if it's true? What if every black hole is a seed, growing a universe from its own collapse? What if the multiverse isn't science fiction, but the very architecture of existence? And what if, one day, our universe collapses and becomes a black hole in another. A ripple, a loop, a cycle without end. Black holes are no longer just cosmic monsters. They might be mothers of creation. And we, our galaxies, our stars, our questions, might be the echoes of something far older, far larger, and far beyond. So the next time you look up at the stars, remember, you might not be looking out, you might be looking in.